Hi viewers and students, this is half-range Fourier series definition. Let a function f of x is defined in the closed interval 0 pi. We may define the function f of x as either odd function or even function in minus pi and pi. So by this consideration, the obtained Fourier series of the function f of x is called half-range Fourier series. So in half-range Fourier series, cosine series and sine series is there. Cosine series and Fourier sine series. So what is cosine series? If we consider f of x as an even function in the interval minus pi to pi, we will get a cosine series. It is called the half-range Fourier cosine series. And if we consider f of x as an odd function in minus pi to pi, we will get a sine series. So it is called as half-range Fourier sine series. So half-range Fourier cosine series and half-range Fourier sine series. So this is the problem for half-range Fourier cosine series. Expand f of x is x into pi minus x defined in the interval 0 to pi as half-range Fourier cosine series. So half-range Fourier cosine series means we will consider a0 and an cos nx. The given function is f of x is x into pi minus x in the interval 0 to pi. So let us consider the even function in minus pi to pi as Fourier series of f of x. So Fourier series equation is f of x is equal to a0 by 2 plus sigma n equal to 1 to infinity an cos nx. Now we are going to find the values of a0 and an we will substitute in the f of x equation. Now look at this a0. a0 is 2 by pi integral 0 to pi f of x dx. So this is 2 by pi integral 0 to pi. Our f of x value is x into pi minus x dx. So 2 by pi integral 0 to pi x minus x square dx. Pi x minus x square dx. Now integrating, this is 2 by pi. Pi is a constant. Integral of x is x square by 2 minus integral of x square is x cube by 3 between the limits 0 and pi. So this is equal to 2 by pi of, substitute the upper limit here, pi into pi square, it is pi cube by 2 minus pi cube by 3 minus 0 into this 0 plus 0. So this is equal to 2 by pi into pi cube by 2 minus pi cube by 3. This is pi cube by 6. 2 and 6 gets cancelled at 3. So this is equal to pi square by 3. So a0 value is pi square by 3. So this is our a0. Now we are going to find the value of an. an is equal to 2 by pi integral 0 to pi f of x cos nx. So 2 by pi integral 0 to pi f of x is x into pi minus x cos nx. So 2 by pi, this is pi x minus x square u into integral of v. Integral of cos nx is sin nx by n minus derivative of this is pi x derivative is pi minus x square derivative is 2x. Integral of sin nx is minus cos nx by n square plus derivative of this. This is 0 minus 2x. So this is 2, derivative is 2. Integral of this is minus sin nx by n cube between the limits 0 and pi. Now this is 2 by pi of, here when we substitute the limits pi and 0, sin terms are 0. So the remaining term is cos term, that is pi minus 2x minus cos nx by n square. So if we substitute the upper limit, pi minus 2 pi cos nx by n square minus pi minus 0 cos 0 by n square. Okay, now this is 2 by pi minus 2 pi is minus pi minus 1 whole power n by n square minus pi of 1 by n square. So this is equal to minus 2 pi by pi n square and minus 1 power n plus 1. So pi gets cancelled, minus 2 by n square minus 1 to the power of n plus 1. So this is equal to 0 if n is odd. If we take n as 3, this is minus 1. Minus 1 plus 1 is 0. So if n is odd, this value is 0. An value is 0. If n is even, suppose n is 2, this is minus 1 whole square. This is 2. 2 into 2, 4. Minus 4 by n square. So minus 4 by n square. The required Fourier series equation is f of x is equal to a naught by 2. Our a naught is pi square by 3. Pi square by 3 by 2 is pi square by 6 plus sigma n equal to 1 to infinity an. An is minus 4 by n square cos nx. So for even numbers n equal to 2, 4, 6 and so on, it is the given required Fourier series. So f of x is equal to x into pi minus x is equal to pi square by 6 plus sigma n equal to 1 to infinity minus 4 by n square cos 2nx.